So they moved where screen
Display
mirroring
settings.
is. Yeah, that's where we were. I just scroll up because it used to be right here. Go to use as main display. Can we do mirror? Does that?
There
That's
it
what we
is.
wanted. Boy, they really made that not
There it
obvious.
is.
Okay, so now you're
Okay.
mirrored, and whatever is showing up on here is the same on there.
Perfect.
Okay, so if you're all good, you can just, if you want, you could just even shut the laptop or shut it most of the way, and then you're all set here. Oh, if you need to connect to Wi-Fi for your talk, it's Qualcomm Hall. It's open.
Okay, good call. I was gonna do hotspot, but Qualcomm Hall, it's just open.
Yeah, it should be just open. Don't you do
There it
QS,
is.
do Qualcomm Hall.
Where'd it go?
I'll go yell at people to start pausing more.
This time, yep.
In there, you need
You got the ray tracing going on.
yeah.
Cool.
Yeah, but the post process volume in there.
And backpack was here when I arrived. So this is somebody. Might be good. I'm not 100% sure. Alright, well, so I get started with my intros and then we'll
Yeah, go
do
ahead.
the first speaker. Let me switch nice thing over to the other thing. Nope, not that one. This one. Yay.
Close the laptop, dude.
What? No, I don't. You know, you're good. You're good. I have it just set on the video display, just the camera display. Cool. Hello, everybody. Welcome. You're here in the right place for San Diego Python. I'm David, by the way. I'm one of the organizers. I want to thank Qualcomm for having us here. So this has been awesome that they've given us this space for like a very long time, except when it was under construction, and then they had another space for us. So this has been fantastic. Specifically, the engineering development team, they're the ones who kind of organize this. And Urivan and Drew, who are not in here, but they might have let you in at the door, they've been fantastic in just making sure everything works. Also want to thank my co-organizer, Jeremy, who's not here yet, or tonight perhaps. He's the one who wrangles all the speakers, which I will have to take back on myself because I think he's moving away, sadly. But that's a few months away. So anyway. Awesome. If you do want to help out and be an organizer with that, get in touch. I would love to talk to you about it. And lastly, on the thank yous, I want to thank Neo4j. Neo4j paid for the pizza for the meetup. And yeah, Neo4j provides a graph database that for certain types of operations is orders of magnitude faster than a traditional relational database. And you can download it and run it yourself on your own computer, or you can run a managed version in the cloud of your choice. So it's on all the big clouds, the big boys. So yeah, thanks to Neo4j. Awesome. And the small little pizza, those are gluten-free in case you're you want to do that, that's fine. That's what the little pizzas are. Anyway, okay. Couple small announcements. The Saturday meetup, we have a Saturday meetup. It meets online on Discord, and it's at 10 a.m. It's a little bit different than this. There isn't like a speaker lineup necessarily, but feel free. You can get to the Discord from the website. If you go to sandiegopython.org, all the links to everything, including the live stream. If you miss the monthly meetup, you can get to Discord on there. You can see our code of conduct. You can get to the YouTube to watch all the past presentations and stuff like that. It's all on there. sandiegopython.org. Awesome. PyCon US just finished, actually. I think today was the final day of sprints anyway. But that was in Pittsburgh. The videos from the main core talks are actually mostly already up. So you can check them out. I think they're on pyvideo.org. So you can, and it'll be linked from the website as well. So if you missed PyCon, which I did, but if you want to check out some of the talks, or there's a specific topic that you're interested in, there's probably a presentation at PyCon about it, whether it's AI or web or whatever, and you can check out the talks. It's awesome, and they're all free. Yeah. So they have it on YouTube as well. Yeah, I think YouTube's really nice, but pyvideo.org has it where you can actually like search by topic and stuff like that. So I use that one, but they all go to the same place. PyVideo doesn't host the videos. They're all just served by YouTube, but you have a search interface and stuff like that. And the most important thing, the most important announcement, if you forget nothing, remember this one. On the website, the biggest button on the website is where you can sign up to be a speaker for a future San Diego Python meetup. The reason why this is so important, and I'm going to really promote it, is when we don't get enough speakers, either I become a speaker or Jeremy becomes a speaker. I haven't spoken at a San Diego Python meetup for quite a while, and I am speaking tonight, time permitting. So if we don't have, so anyway, please sign up to be a speaker. We're looking for talks at all skill levels, whether it's like a beginner talk, advanced talk, somewhere in the middle, web, AI, data science, whatever. Like you can become a speaker. 100% survival rate for speakers. Like you can do it. Please become a speaker. You only have to do 7 minutes, so you can do it. Awesome. That's all my announcements. Without further ado, we're going to get over to Judd Stumpf, who is with the League of Amazing Programmers and has a new code clinic and League Labs. Anyway, I'll let you take it away.
Thank you.
And do you have audio coming out of the laptop?
No.
No.
Hello, everybody. So thank you for the introduction, and thank you for letting me speak. Oh, I tend to roam when I talk. Can you guys hear me if I go over? Where's the?
You should stay at the podium.
That's the range of the YouTube camera. Okay, so I'll stay here. So I'm with the League of Amazing Programmers. We are a coding school, similar to some of the other coding schools, with some significant differences. We are nonprofit. That's one of the main differences. But the main thing that I'm here to talk to you about today is the programs that we're doing for advanced students in our industry, in our community. We love Coder School, we love Code Ninjas, we love all those schools. They're great. Our nonprofit mission is get right? So the school is always great because help us mission. But the League of Amazing Programmers, our focus is path to professional. So we start just like this, where they start like pop out in their lessons. We start in just a month. We launched one to talk about is called No Internet. It's called the Code Clinic. So we've come to the realization that AP computer science, the highest level you can get to high school, does not go far enough to prepare young programmers, computer science professionals, or aspiring computer science professionals for college. It just doesn't. It doesn't do enough. So we started Code Clinic. This is free to every person that wants to do it. It's meant for kids, right? High school and around that age. We have some middle school kids that are qualified to take some of these things. And there's intermediate to advanced classes. They're free, they're online. We have free in-person ones too for beginners, but for the Code Clinic, I mean, we're talking like algorithms, like how to work with algorithms, sorting algorithms, bubble sort, etc. We're talking how to set up a Docker container, how to set up your VS Code for Python, right? Things like that. So when you're an aspiring computer science person and you're 15 years old and you're in high school, you're taking AP computer science, it's your first time doing code. Well, what's next? Like, what's next? Well, the next thing is college. That's not enough. That's not enough. That's not enough for them. They need more like interaction with code, with interaction with actual development. So that's what Code Clinic is all about. So we developed Code Clinic. We've had, I don't know, 5 or 6 um, sessions so far. I don't know why this keeps going out, but either way, I'll keep going. We've had about 5 or 6 sessions so far, and they've been a huge success. And I think we've had about 40 or 50 kids so far. What we're looking for is more content. We're looking for someone who wants to deliver an hour, hour and a half presentation or little clinic for these kids that really need more so that they're ready for the next step. I think we lost video and audio.
Projector turned off for whatever reason. That's cool.
I'm pretty sure YouTube is still going.
YouTube's still going.
How you going, everybody on YouTube?
So it should be powering on, I think.
Okay.
This looks like it is. You see that? Maybe. Yeah,
There we go.
we're good.
Every time I scroll, it seems to do that. So I'm going to try not to scroll. So that's what Code Clinic's all about. That's really like the tip of the iceberg for us. We decided to take that to like the next level. Like Code Clinic, it's the first of its kind. There's nobody doing anything like this, especially for free, right? As a nonprofit, that's our goal. That's our mission, is to get out there and make kids ready for the next level. Then we decided that's not enough. We decided that really, if you want to have people work ready by the time they get to sophomore year in college, junior year in college, or even graduate, they need to have work experience. And with our research and talking to, I don't know, hundreds of people, it's been pretty obvious that the amount of internships out there for young people, we're talking like freshmen in college and below, is very, very hard to come by. So we started, and here we go again, League Labs. League Labs is our new program where we are delivering real internships for young people, college freshmen and below, recommended completion of AP Computer Science or at least a few years of coding. They are building real-world projects from curriculum development, like the real basic stuff, maybe they just have a little bit of experience, all the way up to neural networks research, and in between there, working on our in-house code server. We have a wonderful code server. I don't know if you guys have ever used GitHub code spaces. Super cool. If you haven't, check it out. GitHub code spaces is great. You can run your Python environment online in VS Code anywhere in the world, really, through GitHub code spaces. GitHub code spaces is great. We loved it, and we started using that for a lot of our classes. But then we found that we were like in libraries or some of these schools with really strong firewalls where they couldn't get 2FA. And so we developed our own version of GitHub Codespaces. We created it. And so some of the kids are going to be working on that, new features and whatever. So we developed League Labs, and we launched this, I would say about 3 weeks ago. And in 1 week, with no advertising besides just word of mouth, we had 50 applicants. We accepted all 50 applicants. And we decided, okay, let's give them a shot. Because who knows how good they're going to be? Who knows how do you interview, a 17-year-old with limited, resume experience? I mean, how do you do that? So we accepted them all. And from there, we decided, okay, we're going to put them on projects. And they're choosing their own projects. We give them a list, and they're making real world projects. And it's going to be self-selective. At the end of it, who knows? Out of the 50, we're hoping all 50 complete it, but we don't know. We're going to find out. So we took this idea and we're running with it. And I think it's going to be a credible asset to the tech community at large. What we're doing is something nobody else is doing. We're offering free internships for any kid that has the ability to do so. And then from there, we go through the selection process, right? They self-select, they finish the project, and how well they do on it determines, okay, are we gonna promote you to Qualcomm? Are we gonna promote you to Intuit, et cetera, et cetera. And from there, we're looking to get some corporate partners here. We already have a few, but we're looking for corporate partners to take these kids, league managed, we're gonna manage them, so low risk to the company, right? We're gonna manage them, and they're gonna build these projects that maybe it's a research project. So Qualcomm has a wish list of things that they wanna do, but it's just not worth it for them to put one of their engineers on the task, right? It's just not worth it for them because it's something just low on their wish list. But you get a team of 5 or 6, high school, really brilliant kids actually, on the task, managed by us, and now all of a sudden they can get this done. So that's where we're going with this. What we're really aiming for is to take the brilliant kids that we have in our community, and there's a lot of them. There's this kid that works for, I like to tell this story. He doesn't work for us. He volunteers for us because he's a freshman in high school and he's already completed our whole thing, which is crazy because most kids take about 3 to 4 years to complete our whole program. It's really robust. He's already completed it, and now he's, for fun, he was in one of my classes. For fun, he's using machine learning to beat video games. I think that's cool. I mean, super cool, right? And got a whole bunch of kids with their own websites. I mean, we're talking 15-year-olds with their own websites. It's crazy. It's so awesome to see the amount of the right word really here is the right word is the amount of brilliant kids that are in our community. And what happens is they get their 4.5 GPA, they get their volunteer hours, right? And then they go off to some school in New York, they graduate, and then they get a job in New York, right? So San Diego has this plethora of talent, and the ecosystem here, the tech ecosystem, it's thriving, it's growing. So our whole thing is let's incubate that, let's drive it to the next level, and let's get the community involved. Let's get the tech community involved, the companies involved at a young age, and this 17, 18-year-old kid who wouldn't have had this opportunity before gets some internship with a local tech company here in San Diego, and now that's their experience. So they graduate from some school in New York, but their family's still here in San Diego. So instead of going, well, the opportunities are here, so that's where I'm going to stay, they go, I'm going to come back home because I know that there's work here in San Diego. In the world of, remote work, that may not be as valuable as it used to be. But there's something to be said about San Diegans working in San Diego in the tech community that they grew up in. So I believe in this, I really do. I think we're doing something unique. I think we're doing something special. I think we're doing something different. And I really hope that the community also agrees with me. And if you guys are interested, what we're looking for is people to run some classes, like just an hour class for our code clinic. I'm looking for introductions to tech companies, some decision makers that might want to jump on board with us, with some of the other companies that are already expressed some interest, and let's make this grow. Let's take this to the next level. Let's really make our young people in San Diego like the premier spot for tech education. With that, I'll leave it up to some Q&A.
What are some of the specific breaks they create 90-minute classes? What topics do the classes cover?
We're open to a lot of ideas. We love Python. Our executive director, this is his favorite language. It's actually my favorite language too, Python. That's why I wanted to speak here. We're open to a lot of ideas. Let's just talk. I mean, there's so much. I mean, if you try to like specify what you can and can't talk about as far as intermediate and advanced topics, then you're just leaving out too much. Let's talk. There's a lot of things that people are interested in. Yeah. Anybody else?
What neighborhood, what part of San Diego are you based out of? Is it, maybe I missed that.
Our main campus is in Carmel Valley. We have teachers all over the county. And we have satellite locations in Rancho Bernardo and like Claremont areas. But we teach everywhere. We have after school programs, so we're all over the county from north to south to coast to east. Yeah, we're all over. Yeah.
What do you see as the difference between a virtual experience and in person?
Well, that's a huge difference. So, but it depends on your audience. So in person, for anybody that really needs like hands-on or constant like work with, in person is king. There's no substitute for that. Online is great for anybody that just generally doesn't want to be around a lot of people, or they've already like educated enough in the field, like programming, that an online class will resonate with them and they'll take something away from it. Yeah. Online is great. We love online. And that's why Code Clinic is online, because it's meant for the intermediate to advanced students. But most of our like beginner stuff that we do, it's all in person. You got to be able to look at that computer and point to the screen and say, hey, see that red line there on line 12? You know, that's what we need to be looking at, right? You got to point out the errors and stuff like that. Yeah.
Do you offer cloud-based type of clinics?
Yeah. Well, cloud-based is, all of our code is, yeah. That's a good question.
I'm talking about infrastructure coding, maybe.
We have not done something like that. We'd be very interested in if you want to do like a quick tutorial with some of the really bright kids that we have. Yeah. Talk to me afterwards. We'd love. That sounds like a great idea. We've done Docker, we've done algorithms, we've done some other things, but we have not done setting up a cloud-based server. Is that what you're talking about? Yeah, we have not done that. That's a great idea. Let's talk afterwards. Okay, thank you, everybody.
Cool. Oh, that sounds awesome. Our next speaker, thank you, by the way. Our next speaker is Hobson Lane, and Hobson's going to talk to us about automating the boring stuff with Pexpect. And for real this time. I think that was a talk on my list another time, and then the real talk ended up being something else, right? That's okay.
Hope I can stay on topic.
No, that's okay. No. It wasn't that you were on topic. It was by design that my notes were wrong. So hopefully you're all set. And no audio coming out of the laptop? Or yes?
No audio. Okay, let's see what we got here. Nothing on the screen yet.
It's not mirroring because you're
Right, I'll set it up. I got it. Exactly. There we go. Okay. Okay, Pexpect. You probably have never heard of it. I hadn't until I came across it, trying to figure out how these guys were testing AI systems to play games. And I'm trying to interact with command line applications like Git. I'm also checking all of my students' Git commits, because all of my students want to use AI for their homework. And so I've had them commit several incremental changes to their program, and I've written some Python Pexpect libraries to use to run some Git commands and then process the output. and interact with Git and try to track down what they've actually done. This is not going to be easy. There we go. So first, I'll talk about state of the art in code generation and AI. I won't spend much time on that since that distracted me last time. I'll talk about GNU Chess. It's real AI, where it actually makes logical and reasonable decisions about moves in a world that it understands, like chess. And I'll show you how to automate the game, and this will be a live demo on how to automate it with Pexpect, how to automate gameplay. So you can have two GNU Chess programs play each other. And you could, of course, automate it by calling out to LLMs. That's what I ultimately want to do, is to test how good LLMs are at playing chess. Because what I hear and what the papers say is that they are horrible at it and start to make illegal moves pretty quickly. But the best setups that I've heard about in podcasts recently were Cursor, which is a VS Code fork. VS Code is sort of open source. It's kind of business source, but they were able to fork it, and they have enough money to constantly be keeping up with Microsoft's certification so that their plugins for VS Code don't break. And Gemini 2.5 Pro from Google seems to be the best that works within that system. Zed is my new favorite on the block. They're ground up editor designed for collaborative agentic assistance in the code you're working on. Did some quick tests. I'm not too impressed with either quite yet, and there's some links. I'll share some links in this slide deck. The slide decks, all my slide decks are going to be at nlpia.org. For those of you who've you can probably guess where that acronym is from the title of the book. Let's see, some other, I'm going to skip all this because that's not what we're talking about today. There are some examples of, I have several examples, links to several blog posts from extremely experienced developers and ops trying to do a lot of things that a Pexpect is used for is in operations. So because you can do command line applications, you can automate interaction with them. You can actually simulate a terminal. So you can, even if you have something like htop that is displaying characters all over the screen, you can follow that with Pexpect and know what's where on the screen in the terminal. So they're really good for automating things like SSH and FTP, and so you can have it simultaneously send out agents to all of your servers and do stuff. So if you're running a botnet or a corporate network trying to defend against botnets, Pexpect is going to be a good tool for you. And so anyway, an operations manager who's using it and using LLMs to do some of that automation pointed out that it just doesn't scale to use LLMs to do all that work. And so he switched over to Pexpect because LLMs take a lot of time, a lot of money, and they get things wrong. And you end up having to babysit them much more than you have to babysit your scripts, which also sometimes fail, but they fail in more predictable ways. There's another blog post and other applications. Anyway, I'll skip on to the good stuff. Some games are a really good way to test AI because they're usually easy for humans, especially if you have experience playing the games. And they're hard for LLMs, or large language models, or AI. So board games like Landlord's Game, Jeopardy, chess, these are gradual progressions. So Landlord's Game was invented back at the turn of the century, turn of the last century. And Jeopardy was solved by IBM Watson 20 years ago, long time ago. Chess was solved by Deep Blue pretty soon thereafter. Video, solved in the sense that can beat any human. Video games have been solved by Google and DeepMind. Go was also solved by Google. Google has taken the lead now in all sort of reasoning, actual intelligent agents in the world, despite what you hear from the hype of OpenAI. They only release things that they understand, and they understand the world of AI much better than anyone else. So they progressed from video games to AlphaGo to AlphaGo Zero, which did not even need to be told the rules of the game. It just had to play or given in any seed moves that are used by experts. It was not trained, it just played itself. So all it had to do was have a simulation of the game and tell it when it got moves wrong and when it got moves right and when it won and when it lost using reinforcement learning. That's what someone asked about last month. AlphaFold then applied that same sort of reinforcement learning to folding molecules to create drugs and chemicals. AlphaEvolve, I forgot what the one was between AlphaFold and AlphaEvolve, but there was another one in there. AlphaCode, I think it was. It also generates pretty good code. And AlphaEvolve is now generating awesome code. Code that is inventing ways for Google to save 1% on their power budget by creating a new mathematical algorithm for doing matrix 4x4 matrix multiplication. Think about that. That's only 16 by 16 times 16 total possible operations. It's previously been simplified down to 49 multiplications and by a human being, and AlphaEvolve simplified it down to 48. And that's where they got their 1% savings on all their matrix multiplications that they're doing across all their server farms for all their AI. So it's the first invention by AI, and it did not come out of OpenAI, which, by the way, is not open as much as Google is. I'm not a good fan of Google either. They're a big, horrible company just as much as OpenAI, but they have smarter machines that we're going to be the slaves of sooner than the slaves of OpenAI. Arc Prize is the game that I'm most interested in now because it's measuring true intelligence. It's the abstract and reasoning corpus. It's a corpus. Does anybody know what a corpus is? Yes, a body of a special kind of information. What's my book about? Natural language documents. So, or any documents. A corpus is typically a corpus of documents, a collection of documents. Anyway, so how is this a corpus? How can you do it? It's a corpus of JSON documents. And it's a two-dimensional grid. Don't have any pictures. I've talked about it in the past, so I won't talk about it too much more now. But it's a game where you have to predict what the transformation was from one image to another. Low resolution images, it's image generation, just like what Perplexity and all the clever AIs are able to fake it right now. But you need to do it in a reasoning way, where you actually recognize objects in the scene and they have relationships to each other and they change colors. And there's even a language that's sometimes proposed in a single frame of a single image. And you're given a few examples, like 2 or 3 examples, and then you have to predict what the output is for the third example, for the fourth example, or the last example. So really difficult thing for machines, really easy for humans. So they made sure of that in the most recent version of it. It was, anyway, it's a really challenging game that seems very easy for humans. So it's a lot of fun to play around with, trying to write algorithms that can mimic that intuition that we humans have about what the three main things you're trying to do. Abstraction, so trying to figure out how to represent that data, not as a bunch of pixels, but as objects. And that's the second thing, the fundamental skill that we have, recognizing objects, things that go together, pixels that are attached to each other in some physical world in our imagination. And so imagining that sort of transformation of objects rather than transformation of pixels. That's a really hard thing for machines to grok. And the last thing is compositionality. So doing one thing and then doing another thing to that thing in a chain, composing a sequence of operations together into a program. And so that's what makes this so challenging. Show of hands, anybody who's played Landlord's Game? Nice. Show of hands if anybody who's played Monopoly. It's the same game. The only reason why there's actually two games. Landlord's Game had two rule books created by Elizabeth, I forget her last name, Maggie. She invented it around the turn of the century, just as we were entering the Depression. And she wanted to show how bad landlords were and how horrible monopolies were. And so she gave two rule books, one where you try to play Monopoly and the other where you try to play beneficent landlord and you cooperate with each other. And so the goal of the game is to maximize everyone's income. And of course, Mattel got hold of it. They bought it from her. They assigned it to a new inventor on their own team and simply deleted her first rule book and left only Monopoly for the rest of us to enjoy. Let's see, where am I? What kind of games are there? How do you measure the quality of a game? So that's an example of a positive sum game where you all do better. It's possible for everyone to do better together. A zero-sum game is a game like chess or Stratego or other kinds of games where there's a score and there's a winner and a loser. And that's the game of capitalism, or at least the way that capitalism is played here in the United States, hyper-capitalism. A negative sum game is that one of those games that I mentioned in the title or alluded to somewhere in this presentation, at least I'm intended to. Would you like to play a game? Has anybody heard that phrase before? Really old movie from my generation in the 80s when, anybody know the name? You got it. Thermonuclear war was the answer to that game by the Whopper, I guess it was, the big supercomputer that was the AI of the 80s. And it was teaching generals how to play thermonuclear war. And the end of the movie and the end of the existence of Whopper was the fact that the only way to win is to not play the game. That's an example. Thermonuclear war is an example of a negative sum game where nobody does better if anyone plays. Where your utility function is negative. Another good thing about gameplay and AI is that it's legal and it's ethical, unlike all the other things that they're doing now to train AI. You can play games to your heart's content. There's no limit on the data. There's no limit. There's no blacklisting that's going to be happening from the robots.txt file. There's no DMCA that you're going to receive from the company's data that you're scraping, and no FBI knocking on your door. Of course, we're not going to have that problem in the United States because everything's legal now. And games are infinite. So right now, even OpenAI is now concerned that they're eating their own tail by generating a bunch of slop and then trying to train a machine on that slop. And so they're realizing that they saturated all the benchmarks because they've memorized all the benchmarks because they've scraped them all and seen them all before they actually tested their system on them. And so now they're stuck because they're out of data. And so they're a one-trick pony now. They can only imitate something that's already out there, and they can't solve things like Art Challenge or actual games that require reasoning. And so they're trying to come up with ways, and they're stumbling finally into this world that Google's been playing in forever, the world of games. And all you need to do is simulate the game. You don't need to even tell it the rules. It'll figure them out as it's trying to, under reinforcement learning. And some command line games. My students are creating a command line game, and that's why I dove into this problem with Pexpect and chess, so that I could play their games in addition to exercising Get to check to see how they built them. So I want to see how well they work and whether an LLM can play their games. Because if an LLM can't play them, then they're probably too hard or illogical or something, because an LLM will guess every possible move that you give it and put it in front of its face. And I should be able to get through some of the games at least. But I've yet to finish it up. Hopefully I'll be done before my students are done with all their exams, with all their projects. GNU Chess, a typical interaction with GNU Chess is you launch it, and then it asks for your first move. E2, E6 is a typical move, typical first move where you move the pawn at row E up to E6. I just want to show you the format of the things that we're going to be sending to GNU Chess on the command line through Pexpect. And it also, as you enter that move, like E2, E4, it'll echo back a picture of the game board. It's just showing you that black is at the top of the board and white is at the bottom, and that E2, E4 move that pawn from the bottom. The white pawns are in capital P's. This is another reason why Pexpect, it's one of the example programs in the Pexpect repository on GitHub. And so I thought it'd be really easy to do this demo, but as you'll see, it was not, because they have 3 different versions of that example, and none of them work. At least not with my version of GNU Chess on my version of Linux. It has an ANSI terminal. I mentioned that earlier. So it'd be great for playing games like Rogue or parsing the output from HTOP. It'll also work on Windows if you're running SIGWin, if anybody knows what that is. So you need to have a terminal as a parent that's actually where Pexpect is running. So if you want to output it to that, output those control commands like moving the cursor around and displaying the stuff that you're seeing, that the Pexpect is seeing. So keep that in mind if you're going to ever use Pexpect for your own problems. I'm going to use the simpler way where everything is just a single line. I'm going to only look at the last line, and I'm going to only enter commands as a line. And we should be able to do it live. So after you enter your move, it's going to display thinking. There's an easy mode. I guess I'll launch it in easy mode when I show you the demo so it doesn't take up too much time and burn up my laptop. But when it's in thinking mode, it will always be thinking, even when it'll be always working down the possible tree of possible moves all the time, even when you're moving, when it's not its turn. Even before you've made your move, it's trying to guess what your move is going to be. But easy mode will turn that off with -E. So this is the move that it made. Of course, it matched my pawn. And it's actually reasoning, and it will show you an actual chain of thought. It will show you all of the best branches that it found in the game of chess. Those long strings mean something to a chess player. They don't mean anything to me. But it will one thing that does mean something to me is you notice that the first move, the number 1 at the top, there's actually 2 possible paths. It's exploring 2 possible first moves there, or second moves on that number 1 line. At least that's the way I interpret it. It's also got a score there at the beginning. That's what's used for reinforcement learning in a reinforcement learning system, but this is just maximizing that number, which is basically your the likelihood of winning. The score represents your likelihood of winning and how many pieces you've captured, that sort of thing. There's some other numbers that I don't know what they mean, including really big numbers. I have a feeling that's the combinatorics estimate of the number of possible paths that it's explored in order to find that particular sequence of moves. That's about it on GNU Chess. That's the easy mode. There's also UCI mode. That's not UC Irvine. It's UC Universal Chess Interface. It's a different version than Xboard. Xboard is the original way of interacting with it the way that we're going to do, where you enter these two to four character commands as the moves, and that's what it outputs. Xboard, it means you have some sort of a graphical display outside of the engine, and all it does is give you an engine to play with. I don't know how to use either of those modes, so I'm not going to show it. Okay, that's it. Let's go to the demo. Oh, this is going to be a challenge again. Fortunately, I've already got it running. You can probably hear my fan going. But so you need to, with Pexpect, of course, you need to import it like any other. You can pip install it, and you can, let's go. Here we go. So I don't know if you can read that, probably not. I can't, so now it's better. So now you import Pexpect. I like to call it PE. Then you can create as many instances of Pexpect as you would like. So you can fork the process so that you've got multiple processes playing each other, which is what I'm doing here. And that's why it was burning up my laptop fans when I started playing, because it's thinking in two places about two opponents, about both opponents' moves. You also probably want to record all the output that you're getting in a list. So for my novice programmers, a really good way to store any growing list of or lines of log outputs is with a list. You can just append to it as you go. As you launch, you give the spawn command or the spawn method a command line app. You can include your options in that string. It's just a string, just like you would have typed, and it will send that string to a terminal and give you the output. It won't actually flush that command and retrieve the output until you ask it to do that and to connect up the standard output to your program. So using the expect function. What this does is it's waiting for a regular expression. I forgot to put the R in front of my regular expression in the past and used backslashes inappropriately, and it yelled at me. That's what you were seeing at the top of the screen earlier. But if once you put in the R, everything works great. I'm looking for the word chess to know that I'm in the game and it's running. And then you can see what happened before that string and what happened after that string by looking at your process. I named my process white for the player who's playing white. And then you can see all the responses from that. I appended that before text, the text that came in before the word chess, and that word was GNU. And then I decided to rename my responses to befores to make it easier for me to remember and type. And then we've got afters where I'm appending the white after, but I forgot to instantiate it, so here it is again. And the white after is going to be all the text that happened after. And it looks like that's going to include the regular expression, include the dot star, and it does include text that happened after it. It's basically after the start of your regular expression. And now you can send it a command as if you're at the keyboard. And so it's going to type the characters go. It gives you the number of bytes that were output because it also output a new line. So 3 characters went out. And I can put the afters and the befores. I can populate those and see what's in them. And I didn't spell befores correctly. So I'll do that now. Let's see where we're at. For anybody who's newbies to Python and IPython, you get this up arrow effect where you can go back to previous commands and repeat them. You notice it's not printing out like you would like. All those new line characters are coming across as characters rather than as actual new lines. Why is that? Can anybody see the slight misunderstanding I had in recording these strings? David, you're an expert. You don't get to answer. Yeah, exactly. It's that little b at the beginning of the string is what Ray noticed is the problem. That means it's a byte array rather than a Unicode array. So we need to decode that. So go inside of here and hit decode. Decode it. So Python, when we moved from Python 2.7, I think it was, we started making strings, Unicode strings, the default, and bytes, the special one where you needed that character. And so decoding, it's really hard for me to remember whether you're encoding or decoding, but a good way to remember it is things like emojis and all the Unicode characters for Chinese characters and Japanese and such. That takes a special language that you need to represent in some new code in the old language of bytes, where you only have 26 letters and a total of 128 possible characters of any type. And so you got to compress, you got to put several different bytes together, and that's you're creating a code. And so you need to decode it in order to get back out the things that look natural to you. So you can think of it as a secret message that you've got to decode. So bytes need to be decoded, and if you want to create that secret message, you've got to encode Unicode into bytes. It's a good way to remember it. So anyway, let's decode it and print it. And now those new lines are appearing like you would expect. And this is what you would see if you were actually playing GNU chess from the command line. So now let's create, let's see what the move was that white did after I sent it go. Let's see, let's append to the befores, to the afters. Let's append the after. Let's see what came after that prompt, where it was asking for a move, and I said go. Looks like nothing. Oh, I haven't looked at it. So the world of terminals and ANSI is entirely in ASCII. ASCII and ANSI is ASCII. It's an ANSI standard. That's why it's outputting bytes. Don't see the move here. So we've not yet done an expect. We need to tell white what's going to happen after. What are we looking for after a move is done? Oh, I've got an incorrect. I got confused by that B. Does anybody see what's wrong with my string here, that my regular expression? Does anybody know what I should be doing slightly different? Don't look inside the regular expression, you get lost. You got it. Ray's the winner on that one. Again. So I did a white expect. That doesn't look good that it's sending me 0. It's like that never happened. So I may be having trouble with this particular engine. Let's see. Okay, it did receive the prompt, but let's see what happened before. There we go. That's that board we saw earlier. So let's print that out. Let's do the befores append. I should probably be decoding it as I'm appending, but let's do the afters now. And now let's do the.
Can you write a script or something on the Python thing to run this thing?
That's the whole, I am writing that script. You can dump this to a script and then you can put it in a for loop or a while loop, and that's the ultimate goal. So unfortunately, I didn't get there for this, and that's what I'm going to do for the students. But I imagine y'all are getting bored, but if you just want to see this one little step that will give you all the pieces you need to do this yourself and actually connect all the pieces together, you need to take this afters, the befores is where that before string, does anybody see where the move happened, what the move was in the before string that I printed out as bytes? Or printed out as Unicode, so it'll be a little bit easier to read. Whatever. You got it. Have another winner. Glad somebody's getting something out of this. And I'm having trouble typing. Okay. Maybe it's a little more apparent to you now. You can see the E4 happened here. So it said, I said E2, E4 in my move that I asked for when I was playing. It knows a shortcut to that same move, which is called E4, because there's only one thing on the board that can get to E4. So this is part of the UCI standard that you're allowed to make moves that way. And so now I found the move. So can anybody, so I should probably have in my Pexpect a regular expression that captures the move that happens right before the white and black prompt, if I want to grab that name. So I'll leave it as an exercise to the reader or watcher or board attendee to try that out themselves. Any questions?
Have you been able to hook the two processes up to each other yet?
I can do it right now. Now that we know what the move is.
So can you explain what's behind Pexpect? What's it doing?
A lot of stuff that I don't understand, including process management and standard out connecting, and it's doing the same things that you can do in the Python package or the Python object class called pipe. It's piping data to a command line process. So it's launching it. There's also another, there's another way to run command lines, and I've forgotten what it is, but you can do it in plain old Python without the Pexpect package. Subprocess, yes, subprocess.run, I think it is. And you can, so you can run these processes, but this just gives you finer grained control over the characters that are going out on standard out and coming back. It has things like a terminal that you can use to emulate a terminal and figure out where the characters should be on the screen rather than just processing them as strings. So it's just a fancier subprocess. Thank you. Lots of people paying attention today. Thank you.
But it would essentially learn how to play the game, I suppose. Like if you gave it, say, Colossal Cave, you would figure out the game.
When you say it, no, my program's not going to figure out anything because it's dumb. But I would ultimately test an LLM or anybody who claims to be AI, who claims to be an it that is smart. I would pipe their output into this game, and I'd pipe this output into their LLM to see if they are blowing smoke, and they are. It's just managing standard in and standard out, if you're familiar with C software development. There's no I in LLM, or the I in LLM means intelligence.
I like the slip up the other day where it was A1 and now they thought it was A1 stuff.
Yeah. Thank you, Hobson. Ray, you're our next speaker. Oh, yeah. Ray, you're our next speaker, and you're going to be talking to us about a risk-limiting audit of an election in Streamlit. Oh, we haven't seen the Streamlit presentation in a little bit, so this will be a good one. Get everything set up here. So you want to plug into this thing?
It's HDMI.
It's HDMI?
Yeah.
Okay, well then that should just work. Okay. Is it on that side? And then is there audio coming out of the
No.
laptop? No audio coming out of the laptop, so it should. Okay, so what's on there is the same as what's on the thing behind you. And
All right, so hello there. How many people have heard of Snowflake? Okay, a few. How many people have wanted to make a nice little visual app with the charts and stuff and sliders and inputs, but decided it would be too hard, and so you didn't do it? You just use the command line. Me? Okay, well, you're in the same boat then. All right, so let me show you this stuff. I have a presentation mode here to talk about something that I recently discovered, Streamlit. Okay, so this is I don't know, okay, maybe you can see that. This allows you to make apps with GUI controls, all in Python. Good for students, by the way. You don't need HTML, CSS, or JavaScript. The script runs top to bottom. So it just really, you get immediate activity, immediate reactivity to it. I'll show you that in a second. And there's widgets, sliders, select boxes, number input, and the UI controls, when you change it, it reruns the script top to bottom. Now you may want to control that inside to not rerun everything. I had to do that with mine. And then you can have what looks like live plots. You can have session state and simple deployment. Now let me show you my little script that I made. And it's in the browser here. So that's the plot there. And we have the title here, which is, you can just put this in Markdown. You can have about the simulator. I have that be a little twisty opening thing, so you can read that. I'm not going to go into any of the risk limiting audit theory tonight. I'm going to talk about just Streamlit and how you can use it with your Python stuff. All right, so here, if you don't want to learn this, then you click that again and that goes away. And then you can select, you can have pull down lists here. I have a preset, and then it selects, you know, you can either put these numbers in or use the presets. You can use sliders here to change the samples per trial, change that around. And notice this one here, the samples displayed. If I move this down, then the maximum changes there because you can't display more than you have. So these controls are understanding each other. Of course, I had to put that code in there to do that. But then you can have check boxes, all kinds of different controls. These are all in Python. I'll show you the code in a second. And then when you're ready to run the simulation, I press run the simulation. Now this is running on the website in the cloud. And all you have to do to get to that is very simple. I'll show you that here in my presentation while that is running. So next slide is very simple to use, okay? You install Streamlit. You say Streamlit app.py if you want to name that anything you want, but that is going to be your app. That's where you have your visual controls and stuff. And that could be your whole program. I had another one, main.py, which is actually, I don't think that's the name of it, but it's the core calculations, but you can have as many of these as you want, of course, any Python. And then you need a requirements for this to work and deploy. Anything that you're importing, you're going to have to specify it in requirements like you usually do. You can run it locally with this Streamlit run Streamlit app.py, and it runs it locally. You create a GitHub repo, and every time you push it out, once you link it to the Streamlit cloud, which is free if you're on the free tier, which I am, then it deploys on every push. So it deploys it to the cloud, it gets updated. And you can also deploy it other ways. Now, I mentioned Snowflake, because I didn't even know about Snowflake, but my son said, Dad, did you hear about Snowflake? He's now working in Denver for a company. And I said, you know what, I think maybe I have, but I looked into them. They recently had the largest IPO in history, $3.5 billion. So now you feel stupid, don't you, if you didn't raise your hand that you know about Snowflake. Anyway, what they are is a layer on top of all the clouds. So if you take AWS Cloud, you take Google Cloud, and you take Azure Cloud, they have a layer on top. So they all look the same. And now you can have your data here, there, everywhere. You can have mainly SQL, the Snowflake SQL dialect, which is standard now, so that if you're a company and you have a data store over there and one over here on Google Cloud and Azure, you go, I don't know what to do. Snowflake solved that, and that's why they're a big deal. Well, they bought Streamlit, so that's why they're connected. And so I thought I'd mention that. So I had a running R implementation of this simulator from 2019, and it had CLI arguments. I wanted to translate it into Python for a long time. By the way, AI helped with that. You know, I said, translate this from R into Python. Did a pretty good job, but screwed up a bunch too. And then I added the Streamlit app to get the UI controls and additional logic to get the sampling done. Let's go back and see what happened here. Well, it gave me my nice little chart, which I can quickly change without redoing the whole simulation, because what the simulation is basically each one of these red lines, and there's 1,000 of them. They have 1,000 samples each, so there's 1 million samples up there, and there's another 1 million down here. And then what it does is it figures out how far you need to go to separate the red stuff from the green stuff. So what we'll do here is turn off some of these plotting controls. Like I'm going to turn off the trials for H0 and H1, and now you saw how long it took to run the simulation before. It won't take very long because all it did was change the plot. So if you do have a fast one, and I do have one here, that is a local one. And I say here, this is the one that was running locally. Let me turn that off. Why is that not working? Control C. Okay, well, let me just start a new new shell. And then if I go to the folder that I was in there, audit, and I have a simple one here, Streamlit test. So if I say Streamlit run Streamlit test, I think that's what it is. That works. That's not it. Well, history will probably have it. Here it is. Streamlit run, Streamlit Al, that's the main app. So that should be
It's not in the path.
test. It should work. Is that what it says, not in the past?
Anything that starts with Streamlit is not gonna work until you install Streamlit.
You might need to activate a virtual environment.
Oh, that's right. I need to do that. Virtual environment. Back here. Where is it? Who knows how to do it?
Control R.
Is this Windows or Mac?
Windows.
To run?
Yeah. It's VENV311. Well, that's,
Will you need to also be in the directory that you put the virtual environment in?
you know what? I don't think I have one here.
You just have to install it, it'll probably happen fast.
You might need to require.
Okay, give up. I'm going to this one. Why is this one not working on me here?
Do you use Conda for your environments?
No, that's what it was. Okay. Well, of course, demo has a screw up. That one, I'll just ignore that one. So let me show you instead, because this will be more interesting. This is for this simulator that I showed you before. This is the Streamlit, the app part that does the UI stuff. Now let me push this out of the way and make things all bigger. Control. Is it just because my keyboard isn't on? Keyboard on this laptop doesn't work, so I have an additional one. And it seems to be working. Okay. Zoom. Zoom here. Zoom in. Control. I got a Shift plus. No. All right, well, that's a little better. So you say page title, and it's wide. That configures your page. Then you say, I want a title, RLA simulator. You want an expander, so that thing that opens up. Then I have just plain old markdown here. Do whatever you want. I set up some columns. I set up my presets thing here so I can have essentially a dictionary of dictionaries with the name of the presets. So what that was doing was doing that list of presets at the top. So if I go to default here, choose a preset, it gives me some other values. And if I choose the Nevada 2024 presidential election, then it gives me the actual vote counts from that, which you have to put into the list, obviously. Whatever you want to preset. Then you can set columns. You say with column 0. Now I said that there was going to be 2 columns up here. So I got a 0 and a 1. Now I set up 4 columns and I have 0, 1, 2, and then you have a number input. You say what the heading is for it, the value, a key. So this key is what you find later in your program for that value and a dictionary. And so that's all the input there. And then run simulation. Then it goes over to my other code, which is the stuff that I translated from R into Python. And there's a main, and I had to rig this up, so I had to get the state so that I didn't always run the whole simulation. I had to see what state changed. And if it didn't require the full simulation to run, then it would not have to run that. But maybe in the future I can show you the election model, because at first I said, oh, I'm gonna have to model every ballot. What's that ballot? Did it have a vote this way or that way or anything? Turns out I only need 9 integers to model any size election. And I use NumPy throughout to do things fast, because that's very close to what R does. And then I generate samples, and then I classify them into those 9 bins with this expression. Interestingly enough, AI could not figure this out. I said, try to figure out a really fast way to do this. It would not give it to me. It would come up with the, okay, we're going to exhaustively search everything. I said, is there anything else? Well, if we use NumPy arrays, I can say this array equals, and then have an expression and find out those bins. Now, what I do is I have a full array of all the votes, and I break it up into 9 different bins, which is how they're affected. In other words, you have just a little bit more on this, because I think it might be interesting to understand that. So there's a vote for the winner unchanged, a vote for the loser unchanged, and a vote for neither one, which is unchanged. Most of the election is going to be that. So searching, so you find those big blocks, define them, how many there are. There's a thing called an overstatement, where the winner got more votes than he should have, and an understatement, which the winner got fewer votes than he should have in actuality. And a flip means these are just one vote overstatement or understatements, meaning you go from a non-vote into a vote, or from a vote for the other guy into a non-vote. That changes it by just one vote. And if you flip one, so if you change, candidate A to candidate B, you get 2 votes out of it. So those are two vote overstatements or understatements. So I take the full range of ballots, break it up into 9 blocks. I have just 8 thresholds to detect. And I can do any size election with the same amount of work, and only 9 integers. Okay, what did I do here? I somehow hit a tab, control tab or something, shift tab, there we go. Okay, so I want to get back to my simulation here. So essentially, when you're doing this, you can clear the cache, you can rerun it, and there's usually in the model it says deploy. You click deploy, and it will help you link it up to this cloud, free cloud. And how did I find out about this? Well, there's this thing called Replit, which was being talked about by a guy in a talk show. So Replit is an AI machine, and it says, what kind of thing do you want to make? And it'll make it for you, right? Well, what's it used behind there? Streamlit. Streamlit's easy enough so that an AI machine can do it. I said, well, that's what I want to use. Forget the AI machine. I'll just use Streamlit directly and get my app out. That's how I found out about it. So bottom line here is that I love this thing. Let me give you the summary of how it went for me. I am very happy with it, and some of the other tidbits. The tutorial, they have a ChatGPT kind of tool where you have a chat thing and you can put in your chat deal, and you can somehow interface it to ChatGPT and other things. You can link it to data sources in S3, MySQL and stuff, and Google Sheets, private or public. That's a pretty cool thing. You have a Google Sheet, which is a spreadsheet. You want to import the data into your app. They've got it all set up. Multi-page apps with dynamic, they've got that. Columns, tabs, popovers, forms, progress bars, spinners, camera, and audio input, which means what? It must be for a cell phone? Maybe. I haven't tried that yet. Pill buttons, which I didn't even know what they were. A bunch of buttons with a word in there, and you can select any one you want. You can upload files. Okay, so this is different than, oh, good point. This is not a single page app that's self-contained and easy to just deploy as a static app on S3. No, it has a back end. You have to have a very simple back end, but it's easy to do. So, but you can upload files and they have caches to maintain state. So if you put a decorator above your function, you can say, I want to cache the result of this function, just like you do now, but it takes it between runs. It'll still be there between runs. Things like date, time, color pickers, and then they have easy charts. You want to make a quick chart, a line chart or something, it's already there. And they have a whole bunch of theme galleries. And I said it was purchased by Snowflake, but it's still standalone. Okay, that's my presentation. And any questions? Jump on this thing because this is really an easy way to make these kind of apps. Go ahead.
Do you happen to know what its license? Is it Apache, MIT?
I can't hear what you're saying.
Do you know what it's licensing?
Yeah, it's a regular, I think, GNU license, Apache GNU, I think is what it is. I think it's an open license. I mean, so I did try to find out if there was some like secret, hook in this, like we capture all of your data or something. I couldn't find anything like that, but you never can tell. What the cool thing was, like with that app that I was showing you, and of course I couldn't get the other one to work, but the other one, the test one that I have, it just had a chart with, you do the slider and it changes the frequency in the chart dynamically. So my chart is a little bit too horsepower heavy, and so it wasn't worth running it each time. But for something like instead of having a Jupyter notebook with the kind of cheesy, cells and stuff, here you can have a really slick looking website and still get your plot and stuff out to really explain stuff. Why was I doing this? This is because people cheat on these risk limiting audits all across the country, and they're not giving enough, not taking enough samples. I can prove here that, like in this case, to do a 5%, you need 386 samples. In Nevada, they only did 220. So they are, and this is if you have no noise at all. So that means that there was no errors by voters making a mistake here and there. And that's just the tip of the iceberg on how bad it is with these risk limiting audits. I mean, I could go on and on because it's my area of expertise. But I will leave it there if there's no more questions. Oh, wait, more question?
So it seemed like you hosted this on the Streamlit website.
Yeah, this is on the Streamlit website. I just said deploy it after I showed you what to do with those very few steps. How to get it up there? You have to go, let's see, this. I can't seem to, this. So here's the deployment. You can run it locally, Streamlit, run, da-da-da. Of course, once you get your virtual environment set up, which I didn't do. And you have to install it, okay? But here, when you deploy, you create a GitHub repo, public repo, not private, okay? So if you do public repo, then they allow you to do this for free. You link the repo to the Streamlit cloud very easily. And look at the name I got, auditsim.streamlit.app. It's almost good enough for a paid URL. So, right now is the time to get in on the gold rush. But anyway, easy to do. You link it, and then every time I push the code, it redeploys it to their cloud. I'm done. And so I just, like I said, I learned about this. I told about the group about it on Saturday, and I did this app just, my free time this week. So if I would do this any other way with React, Flask, all this other crud, I'd be here for another month. Okay, so more questions? Seeing none? Oh, one more.
Can you override the CSS values that get delivered with that page? Or?
Don't know. I don't know. They have a whole theme department though. They have a whole theming thing, so I imagine they can. Okay.
You can access all the Flask app, everything.
I don't think they use Flask, but maybe they do. I think they use sockets. So Flask, they use some kind of sockets.
Flask has all sorts of.
Maybe they do. So in the back end, I didn't even explore it. I just wanted to get my thing done. So, you know. Okay, thank you.
Promise like the last presentation will be fast, because I'm doing it. Hopefully, do you have HDMI? You do have HDMI. Or do you have the other thing? Oh, you have HDMI. Oh, you even have my Apple ready. Thank you. How do I full screen this? How do I like go into present? Is there a presentation mode? Yeah, slideshow. Does this just? Oh my gosh, it was magic.
Jeremy, could you and David put a shout out for anybody who has jobs at their employer at the moment?
Oh yeah, we can do that. Is anybody's company hiring? Or, well, I guess there's two things to talk about. If anybody's company is hiring, I'm happy to like let you do an intro right now. But also, another thing to mention is on our Discord, there's a jobs channel. And you know, while there's like 25 or maybe 30 people in this room, the jobs channel gets looked at by hundreds of people over the month. So if you ever have an open job, that's a great place to put it. But if anybody's company is hiring, is anybody's company hiring? Who wants to just give a shout out about their company? Tough market. Tough market. That's okay. I'll get through my presentation. But if your company does have a opening, put it in the jobs channel on the Discord. Oh, this thing got to the last slide for whatever reason. Awesome. This talk's going to be fast. There's a lot of ground to cover with this title, Structuring a Django Project for Collaborative Development and Easy Deployment. But I'm going to actually stick to some of the decisions and the whys, rather like the why you would do various things, rather than the how, I guess, as much. For those who aren't familiar, Django is a web framework for building web-based apps in Python. You can build literally anything with it. It can host very high or very low traffic sites. Instagram, as an example, some of the early versions and some of the services still are built in with Django. So it can handle very high traffic if necessary. Not everybody is going to agree with everything that I say in this talk, and that is okay. Because again, this is like the whys, and so there's going to be decisions that you have to make yourself, and the decisions are going to be different, potentially for different apps. And it's going to talk about the San Diego Python website and the public repository we have for that. And links to everything will be at the end. This is extremely small, but don't worry about it, because we're mostly not going to talk about file structures in this at all. Instead, I want to discuss about like all the many customizations you can do in Django, lots of the settings, and why you might make various choices when you're setting up a Django project. I would be doing people a disservice if I didn't mention Django Cookie Cutter. Django Cookie Cutter or Cookie Cutter Django it's a sort of meta project to help you get your Django project set up and write some of the initial boilerplate code. And it has some sensible defaults. There are cookie cutters for things that aren't Django as well. If you ever want to start a project in something that's not Django, why would you ever do that? Lots of reasons. But it's a great project, and I don't want to criticize it too much. But one thing is that if you're brand new to Django, it can overwhelm you with decisions. It can ask you all sorts of these questions. Do you want to use Docker? Do you want to, are you setting this up connecting to AWS, the database service, RDS is what they call it. All these kinds of questions, and you may not know the answers to these questions when you're brand new. And so, it takes you through kind of like 30 prompts when you're setting it up. Do you want this? Do you want this? Do you want this? And you may not know the answer to that. And a lot of these questions don't have one right answer. They have multiple answers. You might use it now, you might change later, you might want to structure it in a different way if you were doing that versus, hey, we're only going to deploy this one way ever. So there's lots of choices, and I'm going to discuss some of the choices we made on the San Diego Python website. For reference, we use Docker and Docker Compose on that website. We do not use, or we do use a database, but it's not from AWS. We used Redis until they wanted to charge for us. We turned it off. We do not use Celery. We do not use Webpack for front-end services. We do use SendGrid to send mail, and we use Cloudflare's R2 for user-uploaded media. So there were lots of decisions there, and yeah. A lot of these kind of choices that you might make come from this pretty old writing. Like it was like an article, I guess, from more than a decade ago called the 12-Factor App, and it was kind of how to structure a modern web app was kind of what they covered in there. And Django Cookie Cutter is heavily kind of inspired by the 12-Factor App, and the 12-Factor App doesn't tell you, like, again, it sort of covers the why you might want some of these, not specific choices like are you using this technology, but why do you make various choices when you're configuring and setting up your app for collaborative development and how it's going to be deployed. It's worth reading. There's a link to it at the end. It's short. You can read the whole thing in half an hour. I'm not going to go over all 12 points, but I'm going to touch upon multiple of them. One of them is storing configuration options as much as you want them to be configuration options and secrets and things like that. Store them in your environment. If you want to, if you don't want to store them in the environment, storing them on a single file that you like, this can make sense in some cases, but most apps store them in configuration, environment variables, so that your app can change based on these environment variables. In this case, I have a secret key for Django. The secret key is an important thing in Django. Lots of various security things are built on top of the secret key. It needs to be a secret forever, or you can rotate it, but you should never leak the secret key. So that's very important. And so this app, as structured, won't start without a secret key in production. So you can have the development version start, but the production version will not start without the secret key. Whereas in this example, I also have like an API key for a email sending service, and it will start without that, and it'll use some different default. But if the API key for the email sending service at the bottom is there, hey, it'll use that. And so this way, I can have the exact code exactly as it's going to run, all checked into my repository, and only the configuration, how it will actually work in production, changes. As I said, one really nice thing is that secrets are never, ever, ever checked into version control. This is very important. But it's very explicit on which ones are required, which ones are optional, and that kind of a thing. Cool. Another thing from the 12-Factor App is deploying from version control. So you sort of keep everything as much as conceivably possible in version control. Some secrets are read from the environment, or maybe some options are read from the environment. But this way, you can have multiple deployments from the same repository. You can have a staging server that comes with different configuration options and a production server that comes with different configuration options, but they both use identical code. And so this is really important. This is how you get to reproducible builds. The San Diego Python website is deployed on fly.io, which is a host that has some free, a very generous free tier for hosting a website like ours. And so that's how we're doing it. This is an example of how ours is done. We have what's called a GitHub action. It runs whenever there's a commit to the main branch. And basically, our Docker container is built and uploaded to fly.io. In the past, we were deployed on Heroku. We needed very few changes to change it from Heroku to fly.io when Heroku eliminated their free tier. Some projects, you might keep like a separate release branch, and you only release to production from your release branch. These are all sort of reasonable choices, but this is kind of the setup that we did. One of the nice things is that, we can have somebody author a pull request, and as soon as that pull request is merged, that user doesn't need to deploy the changes. Nobody needs to deploy the changes. The changes are deployed automatically. It also means our deploys are always regular. They always happen the exact same way. There's not going to be some failure with the deployment this time versus last time. You have very, very reproducible deployments, fully automated. One of the last things that I'm going to talk about, and the 12-Factor App doesn't talk about Docker specifically. It actually, I think it might even predate Docker. It's that old. But what they do talk about in the 12-Factor App is they talk about development and production parity. So having a parity between your development and production. And in this case, we've accomplished this with San Diego Python on our own website. We do use Docker. We use something called Docker Compose in development, and then we just use Docker without Docker Compose in production. And the reasoning for this is that this gives us very, very similar, the exact same Docker file is used in production and in development. So we know, hey, at least on our web instances, they're the exact same. The reason why we don't use Docker Compose in production is because we host on a database that is managed as opposed to a database that is unmanaged running in some Docker container where when the Docker container goes away, the database goes away. So nothing like that. But our local development with Docker Compose does use Postgres, so we're not testing against a different we're not developing against a different database than we're running against a production. We can use the same thing with like an in-memory queue if we used one, which we used to, but we don't anymore. And one of the other nice things is that since Docker runs just about anywhere, it can run on a Linux machine, it can run on Windows, it can run on a Mac, it doesn't really matter any collaborator, doesn't matter what operating system they're running on. As long as they're running Docker, they're going to get the exact same setup essentially as we have in production, which is Linux. So yeah, and that works really well. So we don't have to worry too much about, hey, this didn't work on somebody's local setup. If our site was more complicated and used something like a cache, that would be in our Docker Compose setup as well. You can imagine a pretty complicated Docker Compose setup for a very complicated production site. Our site is relatively simple. It doesn't have too much. But this way, we at least have dev prod parity between them. That's another one of the 12-factor apps. There's a lot more to the 12-factor app. I'm not going to touch on all of them, because otherwise this would not be a 7-minute talk. It would be a 20-minute talk. So I just have some resources, links to the San Diego Python website, links to the repository for the San Diego Python website, which includes like how it is deployed, like how it is automatically deployed, everything that's not a secret, all the configuration options, everything like that. A link to Cookie Cutter, a link to the 12-factor app, which is just like an article with like, it's literally just one page and then the 12 pages off of there for the 12 factors where they talk about them. And that's pretty much it. Are there any questions before we wrap up this talk and then the meetup? Nothing? Everybody understood perfectly? Awesome.
Do you have any database migration scripts that run when you, like if your data model changed earlier on into the model, so do you have data migration scripts that run as well?
Great question. And that to a degree is covered actually under the 12-factor app in the sense that the migrations, they should be repeatable and documented and as a result checked into your repository. Our website is so simple that we do not have any migrations that we have written on our website. But I've used the same approach on many other projects, and yes, essentially the approach that Django takes where the database migrations, for example, when a schema changes, hey, we added new fields into our data model, into our database, we need new fields, we need to create these new fields on existing tables, or we need to create new tables, or delete some table, or whatever you need to do. These migrations all become files that are checked into the repository, and then when somebody else wants to run your code, they have to run the migrations, and you can run the migrations forward or backwards, typically.
Our site, is this Read the Docs?
Well, in this case, I was talking about the San Diego Python website, but
Oh, yeah, got it.
I've used a bunch of different, I've used the same approach on a bunch of different sites. But in this case, we're talking about the San Diego Python website for this, because this website is so simple. An app like Read the Docs would have hundreds of migrations. Yeah. Any other questions? When is the next meetup? It is the 4th Thursday of June. Yeah, although the Saturday meetup is every Saturday, but that one is online. But the next monthly meetup will be the 4th Thursday in June. Last call for questions? I think we're all done. I shouldn't talk to myself. Thank you for coming. Thank you to our speakers. Thanks to Qualcomm for having us. Thanks to Neo4j for providing the pizza. And hopefully I'll see you next month. Awesome. Cool. Guess I can unplug this. Awesome.